Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the last class, we have discussed how what are the rays that should be taken for formation of the ray diagram or the image formation in case of spherical mirrors. We have discussed about those convenient rays. Today, we will see how we can apply those rays and draw the or make the image formation for spherical mirrors in case the objects are placed at different positions. Okay, so as we know, there are two kinds of mirror, concave and convex. First we will be discussing the image formation in case of concave mirrors. Okay, so take out your pen and make out the heading, image formation for concave mirrors. Okay, so image formation for concave mirrors. Okay, so let us see what are the kinds of images that are formed for different positions of the object in case of a concave mirror. Okay, so first of all, in many cases the object is at infinite distance for case of a concave mirror. Now this term infinite is quite relative, because for a very small mirror which has a very small radius of curvature, for that, if I say consider the radius of curvature is very small, say consider radius of curvature is about 10 centimeter. For that kind of mirror, an object when it is placed at a distance of say more than 1 meter or say 2 meters, okay, that object becomes an object which is placed at infinity for that kind of mirror. So remember this thing in mind, that when we are talking of object kept at infinity, it is not necessarily that the object is kept at a very far away distance as we generally think of. So the distance can be infinite, can be quite large. 2 meter distance can be quite large if the radius of curvature of the mirror is small in comparison to the 2 meter distance. Okay, fine. So now let us consider first case when the object, so the first case is object is at infinite distance or object is at infinity. Now when the object is at infinity, how the image is formed, let us see. We will be discussing some of the cases and you will try to understand the remaining cases by studying the book. If you have any problem, you can ask in the comment section. We will again explain that formation of image, particular problem that you have. Okay, so we consider a concave mirror like this, and for this concave mirror the object is at infinite distance. So let us consider that this concave mirror has a focal length of f here and twice the focal length is the center of gravity c here. Now you must be wondering that how to draw these figures in your copy. For that I must say, in order to draw the curvature, curved part, this curved surface or curved line that represents the mirror, take the help of your compass, okay, and set a distance of say about 6 centimeter. Okay, 6 centimeter. Take a distance, take a length of 6 centimeter in your compass, set it in your compass, and taking that arc length, draw this curved line, okay, blue colored curved line. Now as you have taken in your compass, as you have set your compass at 6 centimeter length, what happens? This distance actually, this is the C, this is the F, and this is the pole of the mirror P. So what happens according to the diagram that we are trying to draw, this distance from the C to the F now becomes your 6 centimeter distance. Okay, so first draw this part, put your compass at anywhere. First of all, draw a straight line, then mark a point named as C, put your compass at this point C, and then draw the curvature, and the radius of the curvature will be 6 centimeter. So this length will obviously become 6 centimeter. Now half that length, so half of 6 is 3 centimeter. So at 3 centimeter distance from the P, mark out the point F, because as you know that for a spherical mirror the focal length is half the radius of curvature. So use that theorem to point the focus on the focal point. Okay. Now, when the object is kept at infinite distance, what happens? So I am just tracing it off. This distance is 6 cm. I hope you have noted, everyone. Okay. Now, when the object is kept at infinite distance, what happens? The light rays are incident parallel to the principal axis. So something like this, parallel to the principal axis. Fine. And we have to take at least 2 rays. So take another ray coming parallel to the principal axis. And after reflection, what will happen? As you know by the rules, that this incident ray will after reflection pass to the focus. So something like this. And this will be also something like this. Okay. So this is your ray diagram. So as the object is kept at infinite distance, we generally consider that when an object is kept at infinite distance, the rays, incident rays, are almost parallel to the principal axis. So we can at least take that assumption, and it's quite a bit correct also. Okay. So what happens? Where is the image formed, or at what position is the image formed? You can guess, yes, that where the two reflected rays meet. So where the two reflected rays are meeting, it is meeting actually at the point of the focus. So here is the image formed. So here is the image formed. Okay. So this is the point of the image formation I. Now what happens if I consider, or if I just talk about the nature of the image, then obviously nature of the image, first point that should come into mind is it is real. Now when an image is real, obviously it is inverted. Okay, although it is actually a point, it doesn't matter whether it is inverted or upright, but it is inverted. And the third point that comes to your mind, whether it is diminished or magnified. Obviously this image is diminished, and it is not only diminished but diminished to a point. So it is diminished to a point. Diminished to a point. So I hope the figure is clear, as well as the image formation is clear. So it's real, inverted, and diminished to a point. Okay. Now the next figure that we are going to talk about is, say, when the object is kept in between the center of curvature and the focus. In between the center of curvature and the focus. In that case, what happens? Let us see. Okay. I will be not erasing the first 2 points, as those 2 points will remain same. We are just changing the figure in the concave mirror. Okay. So we are going to draw the second figure, and for that we are just going to erase the rays from where the light rays were coming and the image position. Okay, fine. So this is your F, okay, and this is your C. Now when we are considering that the object is kept at in between the center of curvature and the focus, it should be in between this point C and F. Now I should mention here that when you are taking the object height, so consider you are taking an object. So say this is an object placed in between the C and F. Okay, the object is upright, it's just erect. Okay, like this. Fine. Now take you can, for when you are taking the radius of curvature, that is the length of the length between C and P has to be 6 cm. You can take the object to be 1.5 cm or rather 2 cm. It's better to take 1.5 cm, so it will be easier for you to draw the diagram. Okay. Now when you are considering object is kept in C and F, then you can consider a ray which is incident parallel to principal axis. After reflection, it will pass to the focus. So after reflection, what happens? It passes to the focus like this. Okay, and you can take another light ray which will be actually which you can take either to be passing through the focus. It is easier for us to draw that ray. So you consider another ray which is passing through the focus like this, and this ray, what will happen to this ray after reflection? Obviously this ray after reflection will be reflected parallel to the principal axis. So if I just draw a straight line parallel to the principal axis, so like this will be the reflected ray. Okay, so this is the incident ray and this is the reflected ray. So where is the image found? The image is found at some point, somewhere like this. Now what happens, the image actually you can see will be in the inverted way, in the downward direction. Okay, in the downward direction, inverted way. Fine. So this is the object. So if I consider the object to be say AB, the image you can name it to be as B dashed A dashed. Okay, so this is the image. Now if you consider the length of the image, see the if I consider the nature, so I forgot to change the point, our point. So this is the second figure. Object is not at infinity, the other object is between C, center of curvature, and F, focus. Okay, this is the second figure that we are drawing. So this heading is for the second figure. Okay, the figure that is present in the board at this point, at this time. Okay, so here what you see, if I consider the nature of the object image, the image is obviously it's real because two reflected rays actually meet at a point to form the image, and the image is obviously inverted as you can see in the figure. And if I consider the height of the object and the image, see the height of the object is this much and the height of the image is greater than the height of the object. Okay, so what kind of image? This is magnified. So third point that we should be noting is that image is magnified. Image is magnified. Okay, so this is the case for when the object is kept between C and F. Okay, next we will be considering another ray diagram for the concave mirror when the object is kept in between the pole and focus. Object is kept in between the pole and focus. Okay, so object is kept between the pole and focus. So what will be the image formation be like? Let us see. So we are erasing just these parts. Okay, so just let us redraw the principal axis. Here we will be extending the principal axis on the right side of the mirror to a certain extent, as because the image you will see in this case will be found on the other side of the mirror. Okay, fine. So this is C and this is considered to be F. Okay, object is kept in between F and P. So in this case I should be mentioning it. Please take the object height to be small. Okay, say take it to be 1 centimeter, because if you don't take it 1 centimeter, image will be formed, but actually if you are drawing it a small copy, you will not be able to accommodate the whole diagram in a single page. Okay, and it's better to draw this figure in the landscape mode of your copy, because if you draw in the normal mode, okay, it will not accommodate. Okay, fine. So in this case, if I consider two light rays again, one light ray is incident parallel to the principal axis, and after reflection it is passing through the focus, something like this, passing through the focus. Okay, fine. And consider another light ray. So if I just put the light rays, as you will see, will not be actually meeting at any point. We have to trace back the reflected rays. Okay, fine. So this is one reflected ray that is just going back when it is incident parallel, so it will be just going back passing through the focus. Take another light ray which will be passing through the center of curvature. Okay, so it will be something like this. You will have to match these 2 points. Okay, and then join something like this. Okay, now this ray, as you know, if a light ray is incident to the center of curvature, what happens? It actually gets reflected back along the same path, isn't it? We have already studied this. So it will just reflect back along this same path like this. Okay, so incident direction like this, reflected direction like this. Now in this case, reflected rays are not actually meeting, but if we just trace back these two reflected rays, then they are intersecting on the back side of the mirror. They are appearing as if they are being diverged from from that particular point. So if I consider here, the image is being formed at this point, and this image is actually virtual image. Okay, this image is actually virtual image. It is not actually formed. It is not formed by the intersection, actual intersection of the reflected rays. Rather, this is formed by the when the reflected rays are traced back on the back side of the mirror. In that case, the reflected rays appear to be meeting at this point. Now, this is the image formation when the object is kept between the pole and the focus. Say the object is A, B, the image is A dash, B dash. So now in this case, if you consider the image formation or the nature of the image, what is the nature of the image? The nature of the image is it is obviously, first point is virtual, not real, virtual. Second point is it is upright or erect, and third point is it is magnified. So this is the ray diagram. Okay, so with that we finish today's class. In the next class we will be discussing the image formation for convex mirror. If you have any query, please mention in the comment box. We'll be happy to solve your problem. Thank you.